Thank you all for showing up to our presentation on why Total Precast should be your next building system. My name is Michael Bell, and this is Jason Stubbe. I have been with Stubbe's Precast for 5 years now, or coming up on 5 years. I took the program at Console College called Architectural Design and Engineering Technologist. Went through there and got picked up by Jason himself at our networking event, and I've been with him ever since. As you might be able to guess, with the last name Stubbe, he's been around the company for quite some time. I believe it's 15, 16 years now. His first steps were probably in the plant, but we've been within the precast business for quite some time. So as far as precast and Stubbe's Precast as a whole, we've been in the precast business for over 35 years. We actually started off in the agricultural business, making hog feeders. And then in 2001, we kind of slowly brought ourselves into the commercial side when we started producing hollow core slabs, which you guys are probably familiar with. And then in about 2006, we started making beams and columns and walls, and now for the last 10 years or so, we've been in the Total Precast building system. We've done over 35 it says 45 on here. I think our current count is actually closer to 50 right now for total precast builds that we have done within Ontario. So what is total precast? So total precast is becoming a very popular choice, and we'll be diving into that. It involves both the structural and architectural system for your building. So we will give you all your structural walls, floor system, beams, columns, and then we'll also give you the architectural wall panels on the outside that you might be more used to for a cast in place style building. So we are also going to be doing that. So we are basically giving you an entire building envelope to go up. All the components are manufactured in our factories off-site, and then brought and shipped and erected on site. So everything comes in on trailers, and we pick them off the trailers and we'll erect them into place. Typically these buildings are made with standard reinforcing, be it just regular rebar. We also, within our hollow core slabs, will use pre-stressing strands as well in order to do it. We don't do any post-tensioning on site yet for the buildings themselves. We haven't had to run into that type of building system, similar to what you might have on a bridge. But that's just not something that we've had to do so far. But those are basically your standard ones. So the main big advantage for Total Precast is the speed of erection. So this little video clip that we have going on right here, these are two buildings that we built within the KW area. The building on the left-hand side is a 13-story building. We were able to erect that in 9 weeks. The building on the right-hand side is a 12-story building. We were able to do that, I believe, in 13 weeks was that one. The one advantage is we go and we are able to erect a building of about 8,000 square feet in about 5 working days. That includes the floors and the walls themselves. So if you have an 8,000 square foot footprint of the building, we're going about a floor a week. We can sometimes able to shorten that down to about 4 days if it's a really simple layout, but that's basically the governing guideline that we're going with for right now. So the advantage of Total Precast is everything's manufactured inside on a controlled environment. So we are able to control exactly how this concrete is going to cure. It's not like when you're out on site where you don't know if it's going to be minus 20 or if it's going to be crazy hot. You don't know how the guys are going to be situated on that day. Everything's in a closed environment. We have 3 different factories, and our most up-to-date one is actually an extremely automated factory. We use the use of robots and our pallets moving around. So it's going to be similar to an automotive plant where our guys are staying still and the pallets are jumping from station to station. So our guys are able to specialize in a certain task for manufacturing this precast, be it putting in all the additional formworks that the robots might not be able to get to, or be our finishing stations, so we're able to utilize our men to their greatest strengths. All of our plants are CPCI certified, and CPCI is one of the governing bodies for Canadian precasters. So we are both registered for both architectural and structural concrete by CPCI. Every single one of our panels is designed ahead of time, and we'll go through multiple quality assurance checks along the way by both our quality control and our secondary guys. We do automated batching, so we are able to test our concretes throughout the day and each panel itself to ensure that you guys are getting the concrete mix, strength, air entrainment that is specified by the structural engineer. So you don't have to worry about your concrete not getting up to the strength, or it has too high of a slump or anything like that. We are checking that along the way. Another advantage is when we're installing the precast, we can go in any weather pretty much, except for when it gets crazy windy, because you can't erect with cranes when you got 100-kilometer-an-hour winds whipping around. So we are erecting in rain, snow, pretty well any type of weather that can really throw at us. As long as our crane can swing, we're there. We are able to grout down to -20 for our walls. And also for the floors themselves, we can get right around the freezing mark, -5, to grout the floors themselves as well. So even when we get to some colder weather, we're able to keep on going. We're not slowing down your dates. We're trying to keep on schedule. So another advantage is with Total Precast, precast is really the most versatile. Well, concrete in general is the most versatile material. You can mimic whatever you want to make it look like. If you want it to make like wood, we can do that. If you want it to make it look like brick, we can do that. If you want some really fancy kind of metallic type look, we can do that. Whatever is your type of appearance that you want, we can make it achievable for you. Obviously, it's going to come down to cost. The more fancy the facade that you're looking for, obviously the higher cost. So we, with Stubbe's Precast, will try to use our multiple different finishes in order to give you an architecturally pleasing building at also a good price point, something that's going to be financially viable for you guys. So this would have basically a flat panel on it, similar to what you would have for any kind of like almost foundation style wall. It's just a regular flat panel. And we would obviously add some color. We always recommend that when you're going up about 3 stories, once you get past 3 stories, you can't really see much of the texture of the building or the finish. We always recommend switching to kind of a flat finish, because you can still get a color and appearance that you want from that high up, and it's not really, it's going to be better for the budget. You're not paying for a texture that hardly anyone can see. For the flat panel or any panel itself, you can have either just a really smooth kind of stain or paint, or we can also offer you a textured paint where it has sand impregnated into it. So it can go and give you that kind of textured finish that you're used to having on a brick. It's not perfectly smooth, so you can have some coarseness within it as a whole. Another advantage, we're able to go and obviously give you your form liner finish. So if you want to imitate both brick, stone, this is another kind of stone pattern, we can do that. If it's a single tone, like what we're showing here, we can do that in our factory before it comes out to site, our first coat. So if you want to be marketing your building as it's going up, it's really nice to have a single color of stain on here, so that people can get a really clear idea of what this building is going to be looking like, and they're willing to go and buy a unit or like look at renting if it be an apartment. So this is a really popular choice that we have going right now for the single tonal one. This is a couple more examples of form liner. Up at our booth, we're in the concrete pavilion. We do have, our station is all made out of precast concrete. It has a couple of different styles of form liners there. Also the CPCI, we are able to manufacture their booth as well, and there's going to be staining demonstrations going on there as well throughout the week. You can also get an idea of different form liners there as well. So these are obviously a couple other ones, be it brick, stone. This is kind of a rib type finish that is more common on industrial buildings, or there's a wood siding down there. And then another one, if you don't want just a single tone of stone or brick or whatnot, you can get into the multi-tonal kind of stains. So you can go and they'll go lay down an entire base coat, then come and do some spot checks. The one disadvantage of the multi-tonal stains is it can't be done in our factory. We actually will be subbing that out, and they come out on site. So it's going to be a little bit harder to see here. This one's a little bit clear. So this would be just a blank concrete kind of panel come on. You'll have the texture from our form liner, and then they'll come after the fact and do the coloring on it as a whole. So it's going to be just a plain concrete building until they come out in order to make it look really, really nice. We also at Stubbe's offer a white cement. So rather than your natural concrete gray that most people are most familiar with, we are also able to do a white cement finish. So if you really want that nice white cement where you can leave it exposed and have that nice reflection of the aggregates and stuff in that, we are able to do that as well. So nearly any type of finish that you guys can imagine or desire, we can make it happen. Obviously there's going to be certain costs for the type of finish that you might be looking at doing, but we can definitely make your building a reality. One new thing that we just started last year is doing factory installed windows. So if you guys have a punch window style building, we are actually able to go and install them in the factory. We'll ship them to site already installed, erect them. So now you have a weather type building pretty much right away. So we're able to save you on heating costs because that's a direct loss for everybody. When you're just heating the building and it's just got pouring out every single hole of the building itself, you're now able to reduce your heating costs because we're able to go and install the windows in our panels in our factory, ship them to site, and put them in place. The first one that we did, we erected everything and we did not have a single breakage on the windows. So we're very impressed with how it goes. And yeah, we're now looking into doing more and more buildings with it. Another advantage is we're the main structural trade on site. So you're not coordinating with a steel guy, a concrete guy, a mason. No, we're encompassing all that into our scope itself. So with us, even if you have some large openings that you want on the ground level and you need a steel lintel, we're not going to make you guys go out and hire on a steel guy to come in and put in one beam. That's ridiculous for you guys. Plus, we don't want to wait for those guys to actually show up if they want to show up. So we'll be taking that under our scope. Another one is we'll be drilling in all your coring for your plumbing. And so anything larger than 2 inches, we'll be coring those in. We'll coordinate with you guys during the design stage, which we're going to touch on in the next slide, where these are going to be located so we can optimize our spans and slabs in order to figure out where your plumbing is to give you the most efficient building as possible. Also, we'll give the option for exterior caulking as well. The main point of failure on a precast building is going to be the caulking joints themselves. So we are now taking on the scope of the exterior caulking because we're very confident in our abilities to caulk it in order to get it weather tight and waterproof so that you guys aren't having any leakage at these joints. So we are also going to be willing to take on that scope for the exterior of the building. And we do in-house kind of design services pretty much from the start to beginning, from the start to the end. So if you guys have a building that's very schematic and you guys are looking at just kind of what type of building system that you guys are wanting to get into, that's the best time to actually come out to us and meet with us because we have a heck of a lot more coordination up front on a total precast than what you might have on a cast in place style building. With a total precast building, we actually have to coordinate pretty much everything before it arrives to site. Not a lot of adjustments can be made on site because every piece is engineered for a specific task. So what we'll start off, you guys have your schematic drawings. You'll probably meet with myself. Jason might also be in the meeting. And we'll go and help lay out a possible building for you using precast products. We'll locate all your load-bearing walls and your spans on what would be the best and most economical building for us. We'll kind of go back and forth and then eventually be doing some budgeting and give you a budget on what your building's going to cost. If you guys are liking that budget, we'll get signed on with you guys and we'll assign a PM to the task. And that's where we'll be starting the coordination with your consultants and our team. And we'll be needing your mechanical and your electrical, and we'll have our own precast engineer to work with your engineer of record as well, which we'll be touching on as well.
So just one thing I want to jump in there for a sec. So the design build process is actually really important. Just like there's an efficient way to build a cast-in-place building, there's an efficient way to build a steel structure or a steel stud building, whatever your building type is. Precast is the same way. Precast has its own quirks, and I'll get into that in a little bit, but it's really important to bring the precaster in at the design stage of the building. Typically, we're pricing and almost locking in our numbers based on schematic drawings. Where there is no for construction drawings or for permit drawings even available yet. It's very much a design build process because we'll work with the architect because there's things that we can do architecturally that look really good, but there's things that are really expensive for us to do as well. So working with the architect, we work back and forth trying to find the best solution.
During the design process, we use a software called Tekla. It is, in a way, is similar to Revit if you guys are familiar with that. It's a 3D modeling software. So we will be modeling all your mechanical openings into the building itself, all your window openings, and we use this Tekla model in order to for our manufacturing procedure. So like, as I mentioned before, our new factory actually uses the pieces developed from the model itself to be sent to a robot in order to put in all the coordinates. So we're able to achieve plus or minus 1 millimeter of accuracy for the pieces that are going to be going on site. So advantage of it, it's a durable wall that can be left exposed. As everyone knows, concrete is an extremely durable product. So it is nice. You can leave it out in all weather conditions. It's not going to be breaking down too quickly. Also with the finish itself, it's very easy to maintain. So if it does start fading over 30 years, you're able to just go and toss on another coating on top of it and boom, you got a brand new looking building. It's not like you have to rip down the facade and put up an entire new one. You just have to go and put on a nice new coating over top. The substantial completion is in less working days. So all of you guys, if you're a developer, you know you have large loans, and we're able to get you to substantial completion for the structure itself in less working days than what you would be traditionally on a cast-in-place building. Once we show up to site, like we mentioned, we're not slowing down. As long as we have product, and we're going to be making product ahead of time to keep feeding the sites, we're not going to be slowing down. We're going to put your building up so you guys can get your money back faster. So you guys are you're not having to pay as much on your interest. The building can be enclosed quicker, especially with the windows now that we're offering. So you guys can get a weather-tight thing. You're not waiting for people to show up on site. So we're able to give you a nice weather-tight building very quickly. Superior fire resistance and acoustical control. So naturally with precast, we're able to give you a 2-hour fire resistance rating with the hollow core slabs themselves. So you're able to get your fire rating immediately. You don't have to add in your extra drywall or whatever resistance that you need. We're also, for your STC rating, we automatically also have a STC rating of 50 itself. So depending on the thickness of the wall, we might be able to also increase that, but our base one is about 50. Cheaper insurance compared to our wood counterparts. So it's also nice. So for the life cycle of the building, if you're having a wood building, you'd be having a higher insurance rate than what you would for a concrete building. So, and as I touched on earlier, less maintenance compared to the other building systems. So if you ever need to really touch up the building at all, you pretty much are just having to put on a nice little coat of paint and she's good to go. You guys are still gonna have your own engineer of record, and we're gonna also have our own personal precast engineer. We can get into it at a later date if you guys really wanna have more reasons on why we kind of separate this. But we're just gonna kind of give you the options and information on what each engineer kind of is in control of. So the EOR that you guys would be in charge of creates the structural drawings for the permit application, tenders, and construction. So you guys are going to still might need a little bit more for, like, if you're going to do a cast in place foundation wall, they're going to be having to still do those drawings. So any of the cast in place type of work that might be required on the building itself. The EOR will also provide the design loads to our precast engineer that we will hire on for the building itself. As I mentioned, the foundations and the structural coordination and shop drawings. Like, he'll still have to review some of the non-precast elements, but we'll take on pretty much all the precast building itself, similar to what would happen in what you would for a pre-eng steel building. So our precast engineer will go and design the precast superstructure based off loads from the engineer of record. All the precast element sizing along with the supporting structures provided. So yeah, we'll size out all of our beams and columns that we might be needing our walls. And we'll also do all of our connections for precast to precast. And then we'll also give the reactions from our precast building to the engineer of record in order for him to design any elements that he might need. So our precast engineer, like the building itself, everything is engineered and gets stamped off on. So there's very little liability onto you guys.
So I just want to touch back on this slide here for a sec. So one thing that there's a lot of confusion around who does the model. So I don't know if you guys are really into the engineering side, but if there is a couple guys, I just want to clarify something there. With all buildings in an ETABS model done by the structural engineer in order to design the building. So when we're doing one level of cast in place, let's say there's a one level underground parking garage, cast in place parking garage, and then a precast tower above. In that case, we would actually design and do the ETABS model for the precast tower above, and then we would give the foundation forces back to the engineer of record, and then they would design the foundations. The only time this gets a little tricky is we're doing a couple 30-story projects or higher projects where the first 3 or 4 levels can't be done in precast. They actually have to be done in cast in place, and for a couple of reasons I'll show you shortly. But what ends up happening is there's a disconnect between the cast in place 6 levels and then your precast tower above. So the engineer of record should actually do the ETABS model for the entire structure, and we can assist through that process. But there should be one engineer in charge of that entire ETABS model for the entire structure to get the two to work together. There's different layouts. When we look at a building, like Mike said, we do a lot of design build. So we start and we look at it and say, okay, is this a layout suite to suite wall? And what that means is basically we're just using the suite walls as load-bearing shear walls. And then we're going to do a precast cladding that actually hangs off of the shear walls. And so we don't need a foundation underneath the precast cladding. So just your main structural shear walls would be precast. We'll do a couple of hallway walls in the opposite direction if we can, or wherever we can get a wall to drop right down through into the basement to help stabilize the building. But this is your most economical layout. So the first thing we do is we look at the building and we try to make this work. If we can't, we'll go to the next style, which is corridor to exterior. So this is where we use the hallway wall as a load-bearing wall and then the exterior wall. A couple disadvantages with this one is you get a lot of thermal transfer. So your hollow core is all bearing on your entire long sides of the building. So you're going to have a thermal transfer between the hollow core to your exterior wall, unless you use an insulated wall. But in some buildings, due to the structure below or just the layout of the building, if your suites change in size as you go up the building, this is the best option to do. You'll have to get into the SB10 where you have to do the energy modeling to make sure that you're doing the trade-offs.
One nice advantage of actually the corridor to exterior, if you ever end up wanting to switch up your suites later on within the building life cycle, it's actually really nice because you would only have stud partitions between the suites themselves. So you can go and expand rooms or shrink rooms according to what your new use of the building might be.
So the next one is the hybrid layout. So we've done this on a couple buildings because you got to take that hallway wall, because basically we need walls in both directions in order to stabilize the building. So what we'll actually do is we'll take the two end suites and we'll flip them the other way. So we'll take the two end suites and make them basically corridor to exterior, if you want to say it, and then we'll do the shear wall divisions. There's a couple things that helps with is if you want to step up the top levels of the building for penthouse suites, it's easier to step in at whatever increment you want to. So if you want to step in 5 feet at a time or 10 feet at a time, it's easier to do those steps. Whereas if you're doing just shear wall to shear wall and you step in 5 feet, now you've got a line load to deal with within the building. So we've done this, and we'll typically use this, especially if we're doing that step. Load-bearing alignment. So precast has a lot of advantages, but I'd say this is one of our key disadvantages against something like cast in place. It's very important that the line loads line up vertically. So we can't take two walls on ground floor and then put a wall right in between on second floor. Our hollow core floors aren't designed to take that type of a line load all the way up. Whereas if you're doing a cast in place floor, you could probably just thicken your floor to 20 inches thick and be able to transfer the load across to the walls. So when we're looking at projects, so total precast is typically economical we started in the 10-story to 30-story range, but we're very glad to see that we're actually competitive anything down as low as 2 stories. We probably have 15 to 20 4 to 5-story buildings right now in the system that need to be built. So it's very exciting for us to see that we're not only competitive in that 10 to 30 story, but we're also competitive right down to the 2-story range. So as you can see here, it's kind of maybe hard to see, but all of those line loads line up vertically. So if we can't get that to happen, there's a couple things we can do. We can add in transfer beams down below, and then transfer the load onto the beam into some columns. Or if it's the first 2 levels, for whatever reason, you got big open areas, we'll actually recommend that you cast in place those levels and then do precast above. We're about making the best building for the owner, not about putting the most precast into the building. It's got to make sense for everybody involved, right? So this is, so we do total precast, but we also do partial precast. So a lot of steel stud buildings have come to us and said, hey, we need some precast walls to add into our buildings because we can't do the elevator shafts, we can't do the stair shafts. So we've started to do a fair bit of this together with the steel stud industry. So we'll do either their firewalls or their shaft walls. The key difference here is when you're using precast for these, you got to think an elevator box, if it's cast in place, is a box. If it's precast, it's 4 walls. So you can't use the corners to transfer your load, otherwise your connections get very, very heavy. So it's key that you treat, if you're an engineer, you treat each wall individually versus an entire box. Typically, if you're going to use precast for those shafts, we recommend that you add in a couple more shear walls and spread the load over more walls, because your overall cost will still come down. Because if you try to put all those load into those stairs and elevator shafts, you end up buying precast walls at $50 a square foot, where if you spread that load across more walls, you can buy them at $20 a square foot in comparison. So the reason the steel stud guys do this is because total precast has the advantage of having one trade on site. With this, it allows them to just have us for the floors, because we're doing the hollow core floors on the building, us to do the shafts, and then they're doing the steel stud walls. So it still limits the amount of trades on site. So when we look at a building, we try to optimize hollow core spans. So basically the best cost per square foot, or the most efficient cost per square foot, is when we can take the hollow core and maximize it to its length. So 8-inch hollow core, if you can get 8-inch hollow core in a residential setting with hallways, etc., hallway loading, we can go 27, 28 feet. So we'll look at a building first and say, okay, can we get these shear walls to come in at every 27, 28 feet? If so, you get the cheapest hollow core price because it's the thinnest and less shear walls. Whereas if you're doing 20-foot spans, now you're adding in a shear wall every 4 bays, for an example, right? So it drives up the overall cost per square foot on the building. 10-inch hollow core, we can span 37 to 38 feet. 10-inch hollow core is actually your sweet spot for a couple of reasons. One, an upgrade from an 8-inch hollow core to a 10-inch hollow core plank isn't that expensive, but you're able to get an additional 10 feet of space. So as we run the analysis, if we can get those hollow core spans out to that 37, 38 feet, that's always our best cost per square foot. If you go to the 12-inch, you start to get not enough shear walls, and it starts to beef up the shear walls. So that 10-inch seems to work good there. The other key advantage is a lot of the buildings we do have a parking garage below. A parking space is 9 feet. 4 times 9 is 36, so it gives you a little bit of play. So you can basically have a shear wall fall down in between your parking spots and have 4 parking spots in between each shear wall. That allows you to do the whole building as precast versus having to deal with another system or lots of transfer beams for that bottom level. 12-inch hollow core, we can go 42 to 43 feet in a corridor loading. We'll do some buildings this way, just if the suites don't line up for a 38-foot span, they want a little bit bigger of a suite, we'll do it. Yeah, parking or real heavy roof loading, we'll still use some of the 14-inch up top, but it's not going 47, 48 feet up there. So wall panel optimization. So that's one of the things we also look at. The bigger the wall panel, the better cost we can give you. So if we got to pour all little 3-foot by 10-foot tall walls, that's 30 square feet. That 30 square feet still has 2 lifters, still has 2 bracing inserts, still has 4 sides, still has 1 rebar cage that needs to be placed, still has to go through the entire process. If we can get the wall panels 10 by 30 feet, now we have 300 square feet, but we still only have 2 lifters, etc. So when we look at buildings, we really look at how can we optimize the panel length. So a key indicator for us is we try to get a minimum of 22,000 pounds throughout the buildings because it's weight that really drives the panel length for us. So we spec a tower crane or a mobile crane that can at least lift a minimum of 22,000 pounds throughout the building footprint. And that allows us to bring those walls bigger and drive down your cost per square foot. So there's these strip windows that run up the building. So the owner wanted a glazing look on the building, but we actually connected the walls with a little precast piece in behind. So what that allowed us to do is instead of having all these little 3-foot walls, it allowed us to tie this whole panel together as one wall. So it only had to run through the production system once instead of twice. And then same thing up here. You can see really big panels. We just try to really push them as big as we can. And that one's not purple either. So this is getting into the technical, I guess, a little bit. But with the wall panels, so we can provide very large openings for patio doors or big windows. We prefer punch openings because then we can guarantee the opening size for you. So whether we're installing windows or somebody else installing windows, you can have those windows ordered, sitting on site, ready to go in the wall panel. We actually did a job in Elmer, Ontario 2 years ago. He didn't believe us, so he didn't order his windows. But then he went around to measure them all afterwards, and he could have ordered them 6 months in advance. Last year, we built another building for the same owner in Tillsonburg. The windows were sitting on site before we showed up. Some of the key things here. So this is your bearing ledge up top here. So this is just a generic wall panel. So we have 258 bearing ledge. So that's for 10-inch hollow core. Then we need a minimum of 250 mil between the top of the window and the top and the underside of the hollow core. This is for us to provide reinforcing above the window to carry the hollow core. Some other key things is we need enough room in between the window and the edge of the panel so that we have enough meat to provide a column type structure inside the wall. And then these are just our generic connections here, the grout tubes. So this here is a non-load bearing wall. So the last wall was a load bearing wall. This is a non-load bearing wall. So this non-load bearing wall is actually going to hang off of the shear walls. So a couple key things here is we'll leave the mechanical box openings here. So that's for your bathroom vents and stuff. So it can either be at the top of the wall or it can be just above the window or centered. But either way, we need a minimum of 275 across the top of these openings. Because what we do is we run pre-tension strand across the panel to take the load from this knife connection across to this knife connection so that we don't need to take this all the way down to a foundation. So this panel literally just hangs off of a knife connection back to the shear wall sitting here and a knife connection back to the shear wall sitting here. So glazing sections. So just like that panel you seen earlier where we did that recess, this is that same idea here. So this is what we call, this is our most colorful building. So it's not pink, but it's bright red, bright blue, and bright yellow. So it was a student residence in Kitchener-Waterloo. So he wanted that glazing strip appearance coming up the side. So what we did there too is in order to keep the big panels, and we had hollow core bearing here as well. So we have precast recessed in back in behind. This is the Barrow Yards in Kitchener-Waterloo, apartment complex. So you can see the same type of recess detail. So just because you're building a precast building doesn't mean you can't use glazing, but we prefer to have the punch window there to hold the panels together. So this is our typical, so this is a big question always with architects and owners, and it's a very fair question. How do you guys keep our buildings, A, thermal, and B, water protected, like Mike explained? So what we actually did is we got together with EXP a number of years back and did a bunch of water testing. So we blew water and wind at our joints. So we did a 2-stage vertical joint and a 2-stage horizontal joint. So we did a couple different variations of it just to make sure we were comfortable with it. And at the end of the day, we came up with a detail that they'll recommend as well as ourselves. And we're currently got that into Prodemity with OAA to see if they can support that as well. So basically what it is we give you the 2-stage vertical joint. So we'll caulk one bead in 3 inches back, let's say, and then it weeps out just below the floor level or at the floor level, and then we'll have a secondary bead on the outside face. So that outside face bead of caulking is getting all your sun exposure, your rain exposure, any acid rain, whatever may be affecting the panel. It's really just there to protect that back layer, which is your waterproofing layer. So if that exterior bead ever fails, you will not get water leaks within your building. So our typical detail would be a 6 to 8 inch, or so if this is a load bearing wall, we'll have an 8-inch wall, and then we'll leave a 1-inch gap, and then you'll put in a 3 1/4 stud, run all your electrical and everything, and then spray foam the wall assembly. And that basically takes a spray foam across all our joints and ensures you have a nice solid enclosed or energy efficient building. So this here is the side bearing detail. So these are those 6-inch cladding walls that aren't actually bearing down on the foundation. So the load bearing detail, we would have a thermal bridge where the hollow core sits on the wall. There's just no way to get around that unless you go to an insulated wall on the outside. So here though, we can actually keep this wall 2 inches back from the face of the hollow core, and I've actually seen one architect go with 3 inches. So we can actually leave a 3-inch space in between the hollow core and the cladding wall. And then your spray foam or your rock salt, whatever you decide to put in there, can actually run right through. So you're not having that cold transfer at the non-load bearing walls. So this is our insulated walls. So when we're looking at a total precast building, we always put them in 2 places no matter what. One, if you have a stair shaft on the outside of the building, you don't want to have to drywall the inside of your stair shaft. So we'll actually do an insulated wall on your stair shaft so that you have a nice exposed concrete finish, durable finish. Nobody's paying to repair the stair shaft. So we'll give you that 8-inch concrete, 4 inches of foam, and then your 3-inch architectural concrete on the outside, as well as mechanical penthouses. So feedback from some of the owners we've worked with is they don't want to have to deal with drywalling or insulating their mechanical penthouses for obvious reasons. So we'll do insulated walls up there as well. These walls do get fairly thick though, because your structural width is 8 inches. Then you need 4 inches of foam to get our 20, and then you need 3 inches of concrete. So to have a structural load bearing wall, you'll be 15 inches thick. So that's the reason we don't recommend them on the rest of the building, because it really starts to eat up space. It does a couple things. One, it gets a lot heavier, so it's going to drive up cost because now your panels are getting smaller in order for the cranes to lift them, just because there's that much more concrete volume. And you're going to lose real estate because typically you're going to the outside, your boundaries are set by the outside of the building. So now you have to deal with a 15-inch wall assembly. That being said, as energy codes get tighter and tighter, I think we're all going to have to eventually start to look more and more at this. But for now, we would typically just do it in parking garages if required, mechanical penthouses, or stair shafts. That being said, if you had a building, like we're pricing a job right now, it's passive housing. They want R40 in the walls. So we found a special installation where we can get R40 with 5 inches of insulation. And that entire building will be an insulated R40 building. So these are our typical connections. So this is our main structural connection. So this is what gives us our cast in place like connection. So basically in the bottom of the wall below, we'll cast in a female splicer bar. We'll set the hollow core on top, then we'll thread in a male splicer bar into that female. The wall above will have a grout tube located. It comes up 4 feet and then 90s out the inside face of the wall. And then basically we set them down, they drop over top of the splicers. We temporarily brace the wall, make sure it's level. Once we have all the walls erected, we come back and pump all these grout tubes. You can kind of see the top of one there, or this tube here, basically full of grout, and that gives us our cast-in-place light connection floor to floor. So that's the main structural gravity connection that we're relying on to keep these buildings up. As well as we do alignment plates. So typically we'll try to bolt everything we can. So you'll see the bolted connections here, panel to panel, but we'll also do welded connections. So on a high-rise building, your bottom 5 levels will be welded just because there's more load. As we go higher up the building, we're able to put in more and more bolted. We push for as many bolted connections because every guy on the crew can run an impact and bolt the panel. There's only one guy that knows how to weld. So we try to push as much bolted as we can. So this is a little hard maybe to read for the first time, but these are the cladding walls. So this is that knife that sticks out of that cladding wall and bears, you can kind of see the detail here, it bears on top of the structural shear wall. So that knife is basically right there, sits on a plate in this wall, and it spans across like a beam from shear wall to shear wall. Another typical design question that we get asked a lot is balconies. How do we make balconies look nice on the outside of the building? So we've come up with a variety of different ways on how to do this. So this would be your simply supported balcony. So basically we've got a wing wall. You can see there's a wing wall there and a wing wall here. So this is really easy. This is our preferred option as a precaster. A lot of architects would say this is their least favorite. But this here, if you can make this work, is the easiest and the best thermally, because we can actually leave a gap between this wall and the structure so that your balcony, there is no cold any thermal transfer here. If that doesn't work, we'll go to what we call the cantilevered arm wall. We have another name for it too, but it's less politically correct. So basically it's the interior wall is what you're seeing here, and then we form like a beam that cantilevers outside the building. So this way your residents sitting on the balcony can still see past, they're not being blocked by the wing wall, but then you're just having this little arm kind of stick out and carry the balconies. You can kind of see an example of it there, and this whole building's kind of done that way as well. This is really took off. We're starting to design a lot of buildings with this cantilevered arm. The key is we got to have enough wall behind it to help balance the weight. So we need to have basically 2/3 of the weight back inside the building and 1/3 outside to carry the balcony. The nice thing about this detail is you're only having cold thermal transfer for this 400 mil by 8 inches or 10 inches. That's the only spot you're having thermal, because your balcony, you can leave a 2-inch gap between your balcony and your cladding wall that's through your balcony door.
Also, at the end of this panel itself, we've been on a couple of projects. We'll leave a gap, a small gap about 1 inch between the end of that panel and the next adjoining panel within the building itself. So that way the cold can't transfer all completely into the building itself. It's isolated to that panel as a whole.
So this is another balcony. So here we're using the exterior wall as load bearing, as well as precast columns. Thermally, this wouldn't be as great of an option because basically you're having a cold thermal transfer all the way through here. Now, if there's enough room, we could maybe drop down like 1 inch of insulation in between the balcony and the flooring, the hollow core floor, but it's not a true thermal bridge because we can't horizontally return it under the floor. Every building has its unique scenarios where we'll use this one as well. So this is a project in Cambridge overlooking a lake. So they really wanted that open balcony, so we just put a column in the corner to support it. This here is probably the worst option. So basically what this is a cantilever, fully cantilever balcony. The problem with that is we have to take the solid, so the balcony is produced like our wall panels on a solid line production. So it's a different process than our hollow core floor. Our hollow core floor is produced with an extruded process. So what that allows us to do is do it a lot quicker and a lot cheaper for you. So as soon as we do one of these cantilever balconies, we actually have to run right back all the way into the next shear wall. So you're paying for a solid slab for 800 square feet or whatever, 4 by 20, 800 square feet inside the building, or 80 square feet inside the building, plus the balcony. But now you're paying for that 80 square feet at a $20 premium versus just a hollow core floor. Plus you have all the thermal transfer where it runs right back into your floor. So we do this sometimes, but it would be our least preferred option, I guess. So parking garages, just some pictures of precast parking garages. So this is the Royal Connaught in Hamilton. So basically we started right 2 levels below grade there. They did a cast in place exterior wall. And then we did precast shear walls, which lined up with precast shear walls in the tower. We did steel beams, or precast beams, sorry, across to support the floors. And you can kind of see. So a couple things here is we'll do the hollow core floors, and then you have to do a structural concrete topping, and then like a traffic membrane on top of that. We just finished 181 King Street in Waterloo. It's basically 6 levels of above grade parking, total precast, and then 12 stories, I think, or 13 stories of residential condos above that. But the entire building is built out of precast. The other thing we'll do is, so precast beams do require headroom. So in order for us to do a precast beam below your floor, it's going to take 10 to 12 inches of depth in order to support the hollow core. If there's no load-bearing wall above and it's just a drive alley above, we'll work together with a system called Delta Beam with Pico, where we can actually span across there the same depth as a slab. So it's basically a fire-rated steel beam filled full of concrete. where it's the same depth as a slab. Now it can't take line loads though. So it only works if there's no wall above, and it's just drive alley or roofing, whatever it may be. But as soon as we get to the top level, we need to make sure there's a bit more headroom so we can put a precast beam in to carry the walls above. But using the delta beam really brings down your floor-to-floor heights, which has a huge impact on cost, obviously. So thermal, we kind of touched on this a little bit. I'm going to keep running here quickly for time. But layout's important, balcony support's important, interior steel stud wall placement. The best thing to do is reach out into CBCI. Their booth is kind of straight behind us at the show. We have the thermal guide, meeting and exceeding building code. I believe they may have a course tomorrow as well if you look it up, just dealing with this specific topic. Show you a couple sample buildings. The colors are going to be off. But we just recently finished our office in March 1st of this year. It's a fully total precast office. We have over 30 different precast finishes throughout the office. An insulated precast exterior wall. We built this just to prove that we believe in what we do and to give architects a chance. So the easiest way for a customer to see what we do is come tour the plant and then tour our office or an owner to we can show you what a precast building looks like. This is a 4-story in Bloor Street, Mississauga. First Gulf built this one. So it's a stone liner along the bottom, brick finish above with window detailing around the windows. Stuff like that's very easy to do at no cost, basically, like the detailing around the windows. The form liner, obviously there's some cost to it. This is a hotel, so we've probably done, I'm gonna say 6 total precast hotels and probably 4 structure-only hotels, where we basically do just load-bearing shear walls and hollow core floors, and then they're using another system to clad them. But we've done 6 total precast hotels across Ontario, from Sarnia to Niagara Falls to Kingston, Brantford. This is an example of the one in Brantford. So there's a Home 2 on the same site there. We just finished that last year, and then the Holiday Inn we did the year before. This is another hotel in Niagara Falls. Saginaw 2 in Cambridge. This is with Killam Properties. This is a WCRI, so it's a co-op student residence. So the students or investors own the building. It's not necessarily like a typical student residence. This is Riverbanks Lofts in Cambridge. That's those big columns on the exterior. Yeah, so the only requirement we'd have for a precast foundation wall is that you need to be able to excavate on a 1-to-1 slope on the outside of the wall. Because with the precast walls, we're going to have joints that need to be waterproofed. You need to be able to access the outside of that wall in order to do that waterproofing. If you can do that, we've done, probably, I would say 30 to 50% of our buildings would use precast foundation walls. And then the other ones, a lot of our sites are infill sites in metropolitan areas where they have 0 lot lines. So they got to basically drive their shoring, hang their waterproofing, and then do one-sided forming up against it. In that scenario, we can't really do precast foundation walls, but other than that, totally feasible. So total precast, we've been into Ottawa, like we're building a hotel in Ottawa right now. We've been into North Bay. So we're from Woodstock, Ontario. That's where our location is. So far, total precast, because the walls are fairly heavy, we've only shipped them probably within a 6-hour radius. That being said, we've been looking at jobs in Thunder Bay, just because the cost of trades are so much more expensive in Thunder Bay. That it may or may not make sense, we'll find out. But typically it would be within a 6-hour radius. So this is a student residence. This one is a little bit interesting. They actually wanted all the balconies twisted sideways. So we actually had to twist the structure in behind, but the floor slabs are actually running straight, parallel with the street. That's a condo project in Guelph. This is the project that I was talking about with the 6 levels of parking. So this is basically 6 levels of parking garage along with some industrial space or office space here. This here used to be the old brick brewery in Guelph, and they were not allowed to tear this down. So they cut holes through the building, and we made some massive precast columns. And we actually dropped precast columns in and around this existing structure and built the precast building over top. Heritage, that type of stuff, we can work with that as well. This is Phillip Street. So we just recently completed the 3rd tower on this project, and hopefully the 4th one starts next year. Well, thanks a lot to everybody for coming. I do encourage you to stop by our booth. We got some more samples and some pictures of buildings we've done, and we can have an in-depth discussion if you want. as well as CPCI. They're running the demo booth. We've built some precast walls for there. You can see the staining. You can see various form liner finishes. We'll be here afterwards. If you guys got questions, feel free to come up and talk to us. So thanks for listening to us. Appreciate it.